Hi, welcome back. I don't need it. Welcome back. Actually, intro stat students. Today we're going to do another video on in the confidence interval unit number 11, and we are doing. I assume we've done this. We've done calculating, so we are doing this sample size and the margin of error in a z interval for population proportion. Okay, so let's read the question. Studies suggest that about 80% of undergraduate students are working at a job. Researchers plan to do a follow up study with a new sample of students. They will use the new data to make a one sample z interval to estimate the proportion of students who are working at a job. Now, whenever you hear estimate the proportion of students who are working at a job, this is the true population proportion that they want to find, right? Even though this it says here, a study suggests that 80% of the undergraduate students are working at a job. But the researchers plan to do a follow-up study. So they want a new they want to find, like, to see if this is actually true or not true, or find a different study. And they are using a new sample of students, right? They will use the new data to make a one sample z interval, which is used to estimate the true population proportion of students who are working at a job. The researchers plan on using a significance level of 90%, and they want the margin of error to be no more than plus minus 1%. So, in order to, you know, figure out what's there, they ask you, so if we assume p had to be zero point 0.8, what is the smallest sample size required to obtain the desired margin of error? Here, the margin of error is 1%, right? Plus minus 1%, which is 0.01, by the way, right? 1%. So smallest. Now, we now need to understand where the sample size is going to be from, and how do we deal with, you know, how does sample size and margin of error have in common? The reason, the thing that they have in common is this: MOE, margin of error, has this formula, right? Is Z star times it by the square root of P hat times 1 minus P hat divided by N. So this is the formula for the margin of error for sample proportion. And they want this to be less than or equals to no more than 1%, right? No more than, so it's less than or equals to 0.01. Okay? So now to work this out, we need to figure out, okay, how do I find this? So Z star is, you got to use the inverse norm, right? Inverse norm on your calculator. And we get this from here, 90%. So in 90%, all right, in 90% of the confidence interval, so here it's 0.95, or sorry, point nine zero. So the tail end here is 0.05, and here is 0.05, right? Because they're both the same tail, right? They're identical. So Z star is here. Z star is actually kind of like a Z score. It's right here, right? And that's a negative Z star. And they both have the same value, but one is negative, one is positive. Now, on the calculator, inverse norm, calculator always, they're interested in area to the left. Okay, area to the left. Now, in this case, this is what we want to find, the Z star, right here. This Z star and this Z star, They're the same thing. We want to find this. So after we establish that, okay, this is 0.9, right, in the middle interval, and the tail here is 0.05. The area to the left, right, area to the left, I need to add this and this together, right, which is 0.95, right? And if you're using your calculator app, you put a comma, you put a 0 as your mean, and you put a 1 as your standard deviation. All right. And so if you put in your calculator, let me show you. So you go to second vars and you pick inverse norm number 3. Then they ask you, okay, what's the area to the left? So it's, in our case, it's 0.95, and mean is 0, standard deviation 1. Boom, right? 1.645. So the z-score here is 1.645. Is it 1.645? Okay. So 1.645. 1.645. So here is, we can change it to become 1.645 times by p hat. No, they said that the p hat is 0.8. So 0.8 times it by 1 minus 0.8 divided by n. And that is less than or equals to 0.01. So you got to do your algebra now, right? You got to do your algebra to solve for n. Now n is in the denominator, right? Unfortunately. So first thing first, we need to divide both sides by 1645, right? Divide here by 1645. 1645. So calculator, 0.01 divided by 1.645. 0.01 divided by 1.645. And that gives us, okay, 0.0067. All right, so whatever that is, 0.00607. Okay, 0.00607. So this one will cancel off. Here will become 0.00607, right? Square root of 0.8 times, now we know 1 minus 0.8 is 0.2. Okay, divided by n. So now what? Because there's a square root sign, we need to square both sides, right? To get rid of the square root sign, square both sides. When you square both sides, this and the square root goes away. So you're left with 0.8 times 0.2 divided by n. Is okay, so I need to put this on the calculator. So while I still have it previously, see how this answer? I need to square. So put the square here. Right, so I have this value here. All right, this value, which is a really small number. Okay, it's okay. Right, whatever that value is right here. Right, whatever value here is here. Now, I need to now, I hope this is not too confusing. This 0.8 times 0.2, I need to switch this place and this place, right? Just switch it over. So put this value beneath in the divide sign, underneath in the denominator of the fraction, and put this n right there in front. See how this easily works, that n is now greater than or equals to 0.8 times 0.2 divided by this value, right? This question mark value, which we have here. So this question mark value is here, okay? So what we need to do is take 0.8 times 0.2, and then we divide by that value. Okay, so let's go back to the calculator. 0.8 times 0.2, and then we divide by, and then we can go up. Okay, divide by that value and press enter. Wow, 4,329, which means n is greater than equals to 4,329.62, and they want the smallest sample size, right? Smallest sample size. So here, which one would work? So um, we have to round up, which is 4,330. Okay, all right, let's do another one. So, a large restaurant chain is curious what proportion of their customers in a given day are new customers. They are thinking of taking a sample of either n equals to 50 or n equals to 100 customers and building a one sample z interval for proportion using the data from the sample. Assuming the sample proportion is the same in each sample, right? Either the n equals to 50, n equals to 100. If the sample proportion is the same in each sample, what is true about the margin of error, right, from these two samples? All right, so here, what is true about the margin of error? So it's interesting. Margin of error is, like I said, is z star times the square root of p hat times 1 minus p hat divided by n. Okay? Right? So they say here the margin of error from the smaller sample size will be 2 times the margin of error from the largest sample. Um, hmm. So for both, the z-score will be the same, right? The z-score will be the same. The p-hat, say, assuming that the sample proportion is the same. The only thing that will be different, right, is the sample size. One will be 50, one will be 100. Okay, one will be 50, one will be 100. So which one will be less? Which one will be less? So if I were to change this value, the only thing I need to change is that value. This is 50, and then this is z star square times square root of p hat over 1 minus p hat over 100. So this is for the sample size of 50. This is for the sample size of 100, right? This is the margin of error, margin of error. Now, z star is the same. Z star is the same because that's controlled by the confidence level. Both of those samples have the same confidence level. P hat is the same, 1 minus p hat. So they're all the same except the denominator. The 50 here and the 100 here. So this margin of error, right? The bigger the sample size, the smaller this number is. And when this is small, this is definitely greater than. But how much greater? What is the margin of error? How much greater? All right. So here it says 2 times greater. Nope. Just because the sample size is 2 times more. So see how this is 100, this is 50? Yes, sample size here is 2 times more. But because it's divided by, it's in the denominator and it's in the square root, you cannot say that the margin of error will be 2 times or the margin of error will be 2 times less. So that doesn't work. The margin of error will be equal. We know it's not equal. So the answer here is going to be none of the above. Okay, none of the above. Because now this is the answer that I wanted to tell you. The sample size are different by a factor of 2. So the margin of error from the smaller sample will be 1.4. So it's square root of 2, right? Root 2. The margin of error from the smaller sample size, right, will be 1.4 times larger than the margin of error from the bigger sample. Okay, so here, let's do, okay, so same type of question, right? Margin of error is plus minus 3%. Confidence level is the 99, and they want us to find the smaller sample size. So good. Smaller sample size. Margin of error is this formula: z star times by p hat 1 minus p hat divided by n is less than or equals to, in this case, is 0.03, right? This is percent. You got to change it to decimal at a 99% confidence interval. So it's interesting because here where is the p hat? Where is the sample proportion? Now, when sample proportion is not given, right? It's not given. We assume it to be 0.5. Okay, so we know now what p hat is, but what is your z star? Okay, remember z star is inverse norm, right, of area to the left. So this is 99%. So this is, let's say, this is 99, which is 0.99, which means this is 0.005. This is 0.005, because when they both add up, it will give you 0.01. Okay? So area to the left, you have to include one of the tail. So this is 0.995. Mean is 0, standard deviation of 1. Okay? And that should give us, let's go to second, vars. Inverse norm is 0.995. Standard mean 0, standard deviation 1. So it's 2.576. 2.576. So here will be 2.576. So this whole thing is 2.576. So if you were to write carefully out, it will be 2.576 times by the square root of 0.5, right? We assume the proportion here to be 0.5, times 1 minus 0.5, which is another 0.5, divided by n, less than equals to, so close this, less than equals to 0.03. So divide both sides by by 2.576, divide this by 2.576, and this one will be gone. All right, so let's do the math. 0.03, 2.576. So here is in the denominator 0.03 divided by, I'm choosing this, and okay, I get this value, right? I get this value. So this value is 0.01164, 0.01165. So here will be 0.00165, something like that, right? Maybe 0.0116. Why can't I remember it? .116. Okay, something like that. All right, so square root 0.5 times 0.5, we know is 0.25 divided by n. So how do we get rid of the square root? By squaring both sides, right? Then the square root will go away, the square will go away. So let's take this value, right? Let's take this value and square it. Okay, right? Oh, very small number. It's okay. So, right, whatever this small number is, it's okay, right? So 0.25 divided by n. So remember earlier, we actually can trade places with this value and this n. So 0.25 divided by this really small number, less than equals to n. Okay, so whatever this small number is in the denominator now. So 0.25 divided by that small number. All right, so maybe I can show you 0.5 times 0.5 is indeed 0.25 divided by that small value, 1,400. So if the math is correct, n is greater than equals to 1843.02. They want you to find the smallest, right? In this case, we round up. So it'll be 1844. Okay, I hope this makes sense. And if you have any questions, do let me know. Thank you very much. Bye-bye.